So let's welcome Mr. O. Vishveswaraiah. He has over 30 years of experience in water supply and infrastructure development. He has handled large projects of water supply, cross-country pipeline, urban water supply management, water treatment and sewage water plants, irrigation projects, industrial and commercial building constructions, roads and bridges, hydropower and 24/7 city water supply projects. He has done civil engineering with masters in structures and has been working for SPML Infra Limited for almost 28 years, managing urban water supply projects in 66 cities in Karnataka, along with other water supply projects in South India. Mr. Vishveswaraiah will speak on water loss management for resilience and sustainability. So let's welcome Mr. Vishveswaraiah.
SPML is a leading infrastructure company which is doing pan-India basis water supply related works. We do undertake basically government contracts, and we give end-to-end solution from the source to the distribution, so which includes treatment plant, pumping machinery erection, water management. Water loss management is a topic that we have selected because conserving water and improving the revenue of the local bodies is the main target. And this project is what we are discussing today. We have done for Bangalore Water Supply and Drainage Board, BWSSB in Bangalore. And this project is funded by JICA, which is in, and this was globally competitive, and we have won this contract along with the JV of Suez, who's the lead partner. So coming to the next slide. So this project basically is unaccounted for water and leakage control for Central Division in Bangalore. The main purpose of this project is the project which was located in the center of Bangalore is more of a conservative, unplanned town in Bangalore. The pipes were laid during the Britishers period. It's almost 80, 70, 60. It's not countable. All were leaking in the worst condition, where the water supply losses were accounted up to 72% of the supply. So the main client here was BWSSB. Project was executed by SPML and Suez Environment. Okay. So SPML has executed almost 650 projects all over India. Next. So how do we define unaccounted for water? Unaccounted for water represents the difference between the net production, what do we produce in the treatment plant, the volume of water that we deliver into the network, and the consumption. The difference is the net loss that we say that is for unaccounted for water. Or it can also be called as non-revenue water, because the loss that we generate during the transmission and the distribution is a non-generating water, that is non-revenue generating water. So this is the basic formula. Now coming to the, so what were the main jobs that we did is, we ascertained what is the assets, where is the topographical survey, and house to house consumption we customers, we did the surveys. We updated all the assets which were never there in the origin. Historic leaks on the GIS we updated. Networking modeling we did, and DMA design, DMA testing and establishment. So execution of mandatory works. What is this mandatory works is, any pipeline which were below 100 millimeter was removed, and we had to establish a minimum of 100 mm DI pipeline in the city network. So then we established what is the base level of unaccounted water and leakages level. That is, we divided this entire area into DMS, and we could assess what is the level. Then leakage control, how do we control the leakage, and UFW reduction plans we did. Establishment of final UFW level. Our target was to ensure we bring down this UFW level to 15%. Then after doing this, we have a 5 years operation and maintenance. We need to hand over to the department, so that our training was to be imparted to them. So then there was a EPC contract and there is a O&M contract. EPC contract was for 3 years and O&M contract was for 5 years. So in the O&M, what we did is we had a huge network of 790 meters, 790 kilometers, where we should do the repair and its maintenance, UFW monitoring and control, instrumentation which were installed, and communication equipment maintenance. These were the main issues. Now coming here, what was the project area is, we had a 26.5 thickly dense populated area. Number of connection was 89,159 numbers. We had 3 divisions, 6 subdivisions, service stations were 15, DMS were 43 numbers. Network length was 756 kilometers. Average network age was roughly more than 40 years. Now, how could we save this and make this benchmark for the next projects to take over? See, when we established the base UFW in 2017 and presently in May 2023, you could see the net inflow we were drawing about 4,117.64 ml we used to draw. After we did the UFW project, we could reduce the intake level itself was 3,400 for serving the entire population. That means there was a net saving of per 716.45 ml per month. The consumption, you can see the base UFW March 2017, 1911, consumption is increased. The consumption means that gives us the revenue. Earlier, the consumption was only 1,911. Now it has enhanced to 2,719 ml. That means more the consumption, more the revenue is there. So earlier there was stand post consumptions were there. That also has been reduced. Overall, you could see this. We could save 1,533.51 ml per month. That means on an average per day is 51.12 ml per day. So this is going to save us 78.36 crores per annum, which means the project payback is within less than 3 years, considering the cost of production is 42,000 Indian rupees per MLD is the cost of the production. So these are the highlights of the projects where we had 43 DMAs, consumer survey we have done is 89,159. Laying of DI pipeline, these were the mandatory, as I earlier mentioned. Any pipeline which is less than 100 mm were replaced. Any pipe, earlier they had the PVC pipeline were all replaced by the DI pipelines. Then we had the transmission means of MS pipeline 10.4 to augment the supply. Then the house service connections were replaced of 20,000 because they were old and we could see that a lot of water losses were there. Installation of district meters, DMAs in 113 numbers we have done. Consumer water meters, we are replaced 22,833 numbers. Leak attended over 2 types. One is a visible leak which surfaces on the earth is 15,741. One is the invisible leaks. These are mainly due to the cracks that we see in around the pipeline and it doesn't come on the surface. This is called as hidden leaks, which we attend with the new technology, which I was going to explain you in detail. So they were around 8,852 numbers we attended in the span of 5 years. Now, if we look at the graph, but whatever we have saved versus what was the consumption, average initial UFW, when we took the survey, when we took the project, it was 61%. That means if we were pumping 100 liters of water, the UFW was 61%. That means accounting was only 39 liters. But when we established overall, after doing the entire survey, we could regularize on an average of 52.78% was the liquid. That means more than 50% of the water which is pumped was going directly, treated water, which cost was going directly inside the earth. Now the present level, when we completed the 5 years of O&M, was accounted at 18.82, which is a significant reduction. And present of volume of water accounted, that means that if you're saving per month, per day is 51.12 MLD. So we could see this, the graph, how much we could save. This shows 51.12 MLD of water. This can be utilized for other areas where you are unable to supply the water. So in this, what we have traced out is, which is naturally visible, is unauthorized connection. People were drawing water without taking a legal or regular this thing, or 5,981 was detected, and we have regularized that. Number of connections rectified and disconnected. That means some people who are illegally taken the connection were disconnected, and number of connection to be regularized. That means we have identified that the department is going to regularize that. Meter abnormalities is the meters doesn't function properly. That also we identified, and we have given these numbers. So this is the case study that we could find out. Now coming here, this is the analysis that we could make month on month in a span of 5 years, where the UFW levels was brought down to 18.32%. So this is the graph that shows you cannot see a straight line, but you can see a lot of ups and downs, because this mainly contributes to sometimes in February it is 28 days, and in March it's 31 days. Sometimes water doesn't flow properly. So this on an average from this level to 51% to start initial UFW, now presently is 18.28% we have brought down. So what was the basis of this project is all the pipelines which are more than 60 years in old were replaced. We had a lot of challenges which you could see because it is an unplanned area. There were really narrow and congested, heavy traffic. We were forced to work out in the night only. We could not do any machinery excavation because we had a lot of other utilities haphazardly laid. Okay, and we could face the lot of issues is statutory approvals and permission, the local corporation in attending the leaks. So these are the normal issues that we faced when we were trying to reduce this. So you could see from this graph itself, see one is the first in the area, we could see 72.56% was the UFW level, which we have brought down to 11.28%. 64%, these were the number of DMAs that we are telling, 43 DMAs. 64% to 27%, like this. So these are the totally 43 DMAs, where you could see the what is the base UFW and the what is the current UFW that is being present, and the average, if you make it out, if you could reduce it to 18.82%, which is the end of the project, which is far lesser than our targeted of 15%, because we could not achieve this mainly because we do not have the control over the statutory people, because whatever we deduct, it has to go through the normal procedure of going to the government authorities, and they take an action, which is normally is a delay process. So these are the EMF meters installations, where we can measure the inflow and the outflow of the water, and the difference we can find out. So these are the water meters that we are installing. This is the road connections for installations. So this is the MS pipeline that we laid in the busy roads for augmenting the water. So this is one of the technologies, as I told you, how to detect the hidden leaks. That is the leaks which doesn't surface on the road. These are actually, this is a helium gas that we inject it here for the pipeline. Then we put the huge pressure of water. Then these leaks, wherever it is a crack in the pipes, they surface out. So when we surface out, we can make a drilling hole in the pipeline. This helium gas tries to escape. Then we find out somewhere near here, there, it is only a trial and error method. At more or less, this rate of success around 95% success is there. So this is the total live project, which was saving 51 MLD per day, and the water losses has been reduced from 52.78 to 18.2, which is recorded and documented by JICA and the client BWSSP. For achieving this, SPML has received 2 awards, which is the first of its kind in the country, and it was a pilot project. With this, we could receive these 2 best awards for achieving this success in a congested area and an unplanned hardcore city, central city.
Thank you, Mr. Vishveswaraiah, for your insight on water loss management for resilience and sustainability.